Amrit? Amrit, can you hear me?
यस सर, उतना अच्छा क्लियर नहीं है.
अभी?
हाँ, बेटर.
Ready?
यस.
Okay. So now we are going to study about centrifugal pumps. So centrifugal pumps क्या होते हैं? What are they? We have already seen that they are the main pumps which are used for cargo. So transferring liquids, bulk liquids in big amount, big quantity from height, from low height to high height, we need centrifugal pumps. Mostly we are using centrifugal pumps because they are big pumps with big capacity and they can transfer liquids with high heights. Correct?
Yes, sir.
So this is a centrifugal pump which you can see. Centrifugal nothing, there is a like a fan, or which is called impeller, which is like three blades of the impeller, like you have a fan at home, and it is rotating, and because of this rotation it is moving the liquid, and this liquid is going into this pipe and then discharging up to a height. So this is the impeller, this is the casing, it is called volute casing, and how and why it is designed, that we will see. So this is a centrifugal pump. See, when it rotates at high speed, this is how it looks. So generally this impeller or shaft impeller is moved by this electrical motor, where you can see this shaft, and it's such a big electrical motor. Or there can be other things to drive this impeller and shaft. You can have hydraulic system, mostly on ships you have hydraulic system, or you have steam system. For cargo oil pump you have steam system in crude oil tankers. So there are you can have thermal oil on some ships, then you have turbines also, but that is different. So today we just understand the pump. The main function of the pump is to convert the mechanical energy into kinetic energy and transfer the liquid to from one place to another or to different heights. So the parts of the centrifugal pump, first is the impeller, as you can see. It has blades which are like vanes or this thing, and then you have the volute casing, the covering. So you can see here, this is the inlet for the cargo, and the cargo is moving in this what you call volute casing by the impeller, and then it is going in the outlet. So this is a very simple basic centrifugal pump, and this is like a tire is passing on the road. So because of this resistance, the cargo is moving into the volute casing. So this volute casing, the shape is like this, which assists in moving the cargo towards the outlets. Outlet, more cargo can go. So it's converting the mechanical energy into kinetic energy. So the amount of energy will depend on the height to which it has to be delivered, or the back pressure and all. So as per that, the RPM we can increase or decrease. So 200 RPM and 3-inch or 6-inch impeller, it will depend on how much rate, maximum rate of the pump we require, and at what height and distance we need to pump the liquid. Like if you all must be have seen this electrical motors for water in your houses and all. So the places which have got low height of water, we need a bigger motor. So the more the height, the more bigger the motor and impeller we need. Correct. Now the direction of rotation. So generally it is, we think that it could be rotating anti-clockwise, clockwise, but that is wrong. Generally it is rotating anti-clockwise. And because it needs to move the oil or water smoothly. So this is the smooth surface of the blade, and it will move the water smoothly backwards and then put in the outlet. So this is the correct rotation of the impeller, counterclockwise. Now let's see what is priming and why do we need priming. So if the pump is not filled with water or submerged in water, then it will move in air, and which is cause damage to the pump. So before filling it, we fill it with water, and that is called priming. So first we take some water and keep the pump below the water level. That is important in priming. So we keep the pump submerged in some water or liquid, and then you take the suction and move it manually, and that is called priming. So this is the fluid level, and this is the pump level. Because if the pump is running dry, it will damage the blade, and the pump is called aeration and then cavitation, that we will see later on. So the bubbles you can see here, the air bubbles which are hitting the impeller, and they will cause some damage to the impeller pitting or something, which is called cavitation. The cavity, like your teeth cavity is destroyed by the bacteria, the pump's impeller cavity is destroyed by the air particles hitting like stones. So that is called cavitation. Now volute casing, it's a geometric shape like a helical shape or spiral shape. Why? Because that is the best to move the water up, because it is changing the pressure and diameter in different directions. And when the water is moving up, it has a good pressure to go to a good height. And there will be less backflow also to keep the cargo instead of cargo keep circulating, it will push it out with the help of this shape. Now dynamics of pumps, like how the pressure and all is acting. So kinetic energy is converting, and you have a good flow in the what you call pump, and the more the flow, the more pressure will be there on the pump to deliver. And also it will depend on the height of the oil. So if you have what you call this type of height of the tank, then the water will flow in the pump easily. So there will be not, and you have to discharge low, so pressure will be very less. And if suction is low and discharge is high, then the pressure on the pump will be much more. So it will depend, pressure will depend on the flow rate and the height of suction and discharge, and the area of the pipeline also. Small pipelines will have a more pressure on the pump. So you can see here it is same liquid is going, here same liquid is passing in bigger area. So correspondingly, this small pipeline will cause more pressure, big pipeline will cause less pressure. As per Bernoulli's principle, velocity is and pressure are inversely proportional. So if more velocity, higher discharge is there, you will have less pressure. Means if the flow is easy, In the bigger pipeline, then pressure will be less. Now, regarding some maintenance, sometimes if you have impeller is damaged or something, there are some seals also, or regular inspections and all we can do, but generally done rarely in the dry docks and all. Next is types of centrifugal pumps. So we have different types of centrifugal pumps: submersible, deep well, centrifugal pumps. So main thing is people see is your input or output, how much cargo you want to discharge, at what rate and pressure. But also we need to see that if the pump we will put inside the tank, that is submersible, or it is a deep well, means the pump is outside and the well is quite far away, that is called deep well. If it is mounted on the deck, like in some gas carriers. So the types of centrifugal pumps will depend on core design, impeller construction, bearing orientation, driver mounting method, and number of stages it has to pass through, or the cargo has to be discharged. First is the impeller construction. Either the impeller is open or closed, like this. So you can see this is the open impeller, means it's not covered. The simplest design of the impeller, and it has few curved blades which are called vanes, and you have a shaft which is connected, which will rotate this impeller. So this will pump the fluid easily, which has got some dirt also or something. So that will move with this. But if the fluid is much purer, or if it is gas, as we saw inert gas, then you can have the closed impeller. So this is a special chopper blade for moving the impurities also. Now with more, this is a closed type of impeller. If you have this one is much what you call efficient than your open impeller, because it can rotate fast also, and it's closed, so more cargo can move and dirt will not go inside. But it can get clogged with the dirt because it's not moving, the dirt is not moving properly if it is there. Then this is the bearings, which is connecting the shaft to the motor and the impeller. So bearing is important because how fast the pump is running. As per that, if the bearing is not able to hold, then it can cause problems to the impeller. The impeller can heat or not work properly, get imbalanced. So bearing is very important to keep the shaft and impeller in place. So sometimes you can put two bearings also on each side of the impeller, so that big impellers, they keep in what you call place. So these are the types of bearings. You can see one is here to move the impeller. Bearing means this shaft is going here and connected to the impeller, but impeller has to be free. So the bearing is the part which is connecting the shaft and the motor. So this is the bearing, you can see. So the bearing and shaft are connected to the casing, and impeller is free to move. So this is a split case of a pump. Case is taken out, the volute casing. So you have end suction pumps and split case pumps, where the pump case is open. Then motors can be placed vertical or horizontal. Then driver mounting method. So there we will see what are the different type of couplings in connecting your electric motor. Then next is positive displacement pump. So you have, as we saw, positive displacement pump like your hand pump and rotary pump and all. So let's see different types of positive displacement pumps. So this is also one type of positive displacement pump. Which positive displacement means the liquid will move only in one direction positively, it cannot come back. But there are many different types of positive displacement pump. Like for example, on ship, can you name any positive displacement pump on the ship? Or a reciprocating pump?
बैलेंस पंप वही होता है.
Ballast pump is positive displacement pump.
Yeah.
What about Wilden pump?
हाँ.
Wilden pump is positive displacement. Ballast pump will be generally your centrifugal pumps, I think.
एयर मोटर का पंप सर डिस्प्लेसमेंट पंप होता है.
Air motors, yes.
एयर बॉटल.
Sorry? Air bottle. That is a compressor, no? Pump console.
Yes,
So piston pumps or plunger pumps or diaphragm. So your positive pump displacement pumps can be classified in two categories. One is your rotary pumps and reciprocating pump. Reciprocating means it is moving the liquid from one place to another with a piston, and rotary means something is rotating. So in reciprocating, then there are three types: plunger pumps and your piston pumps and your diaphragm pump. Diaphragm pump is your Wilden pump, and piston pumps are there, like your compressors or something, and plunger pumps are there that we will see. So this is a piston pump where the piston, like your pitch, you in Holi, you are using this pitchkari to put the water. That is your piston pump or your injection syringe and all. These are your piston pumps. So you have a cylinder, one side is inlet. When it pushes, you have outlet. So different designs are there of piston pumps. So inlet is coming once you take the syringe or this piston up, and when you put it down, it will push the liquid out. That is your piston pump. So when there is inlet, this outlet is closed to avoid back opposite flow, and inlet is there. When pushing out, inlet is closed and outlet is open for the liquid to go out and not go back in the inlet. So this is, you can see how the actual piston pump looks like, and let's see how it works. So these are the pistons, like you have the pistons in the cylinder of the engine. And this is how it will work. Each piston will go up and down like this. Then plunger pump. Same like piston, but the plunger is like pipe. So again, the liquid will go from inlet and outlet is closed, and when outlet is going, inlet will be closed. So like this, same like a piston, but it's a pipe, and if we need a bigger pump, piston pumps are generally smaller, plunger pumps are generally a little bit bigger. Then diaphragm pumps, diaphragm is moving in and out, like you have this Wilden pump, and if it is getting stuck, you just put, because there's nothing else, it's just a diaphragm gets stuck, so you just hit it with some rod or something, and the diaphragm is released and Wilden pump starts working. So again, it needs suction. So this is the diaphragm which keeps moving in and out like this. So inside is connected to a rod which is lifting the liquid in and out. And this is the seal. Diaphragm is also acting as the seal. Next is rotary pump. Rotary pumps are of different types: gear type, lobe type, vent type, peristaltic, screw, or progressive cavity. So this is what you can write. So this first is the gear type, like you have the winch gear, same way, any gear is there which is moving the liquid, that is your rotary pump. So you have inlet, outlet, and the cargo will be moved. So you can see, because of this, gears are sealed to the walls, so it will move the cargo easily. Then you have rotary gear pump. So that was gears separately. Now this, you have rotary gear like you have in the crane, inside the crane, same like that. So the cargo is moving like this, is coming from here and moving and going like this. One gear is big, one gear is small. One is internal gear, one is outer or external gear. Then you have lobe pump. Same like gear, but it has got two lobes of vanes only. So they are placed in such a way that one lobe is coming after the other. Then rotary vane pump. So you can see same like if this was not there, it's like a normal vane or plates, but one more rotary is rotating impeller is joined to that. And it is little bit offset for the liquid to move. Like you can see here. Then peristaltic pump that we saw in the starting. So peristaltic means जैसे अपनी nerves चलती है ना, blood is pumping through the pulses. Same way this is pushing the pipe and taking the liquid out. Then screw pump. It's like your screws, your drills, drilling bits or screws moving continuously. And with in between these, the cargo will keep flowing and it will keep flowing from outside here. Then last is progressive cavity pump. Little bit similar to screw pump, but there is only one shaft. It's helical, spiral, screw shapes. I am keeping everyone muted. So why you are unmuting? So that is different types of pumps. Now we will see FRAMO pump system. FRAMO is mostly used in chemical tankers and some product tankers also. Can you hear and see the video? So this is a chemical tanker where you have pumps in each tank. and there's very smaller tanks, like this size of chip will have 22, 24 tanks. So these chemicals carry various amounts of parcel and different cargo, different parcel in each tank. That's why we need to have separate pump in each tank. So now let's see the loading operation in a FRAMO. So this is a FRAMO control panel. You can see the FRAMOs are operated by hydraulic pressure. So the RPM of the FRAMO pump is controlled by here. So this is a start stop button and the RPM is controlled here. And the pressure of the pump and the hydraulic system we can monitor from here. So we can do loading, discharging, stripping. So this is a FRAMO pump. You can see there is inside. This is like a volute casing what we saw for centrifugal pump. So FRAMO is a submersible deep well pump, and you have this volute casing or fan which is inside the tank only. So it's always submerged, so we don't need for priming. Then you can also, for tank cleaning, we can use these pumps, loading, discharging, tank cleaning. So this is an overview. You can see the tank and the pump is fitted here. So if you tank is full of cargo, for discharging, cargo will go here, and from this discharging line, it will go to the shore. And then if you are loading, the load cargo will come here and it will go to the loading line in the tank. So first we start with the loading. So we are seeing that connecting the checksums and all. So initially, of course, we should start all the pumps very slowly because we don't want to give the shock, immediate motion shock to the, so very, very slowly we should open the discharge valve and pump should run in slow RPM to see if there is any problem. Sometimes you can have some obstruction, rags or something in the tank. So it should not damage the pump because they are very costly pumps. So slowly open the valves. Even loading time, loading is done by the loading line, but the cargo should be slow because it should not damage the impeller as we are seeing. So this is the proper pipeline. This is a FRAMO pump. The same pipeline is coming here. So you can see that this is a FRAMO pump and this is the discharge line. And if you open this valve, the cargo will go to the loading line, and if you open this valve, the cargo will go to the through the pump only. If you want to recirculate, or and this line is for discharging. You go from here, and you can go here, and this valve will be closed. So this is your FRAMO pump. There will be some hydraulic lines, and this impeller is moved by the hydraulic system. And then this thin line is the stripping line. The cargo is finished. Then after discharging, we will use this stripping line that we will see later on. So the cargo is loaded from the loading line. So this is actually how you see the pump on the top of the tank on the deck. It looks like this. This is the discharge line coming out of the cargo pump. This is the control for the pump to increase or decrease the RPM. And these are the hydraulic lines which is going. One is the hydraulic inlet to pressurized line to move the impeller, and then hydraulic oil will return from this line. And this is a cofferdam purging system that we will see later on. So initially the manifold is closed, and once the cargo reaches the manifold, slowly we open the valve to keep the pump in positive pressure. And there is a requirement, it can hold the maximum loading pressure up to 8 bars. So lines and manifold pressure should not be increased up to more than 8 bars. That we have to keep monitoring. Here you can see it's around 7 bars. So there we have a computer system in engine room to monitor all the line pressures and pump pressures, everything. Then manifold line pressure, temperature and pressures. So as per the cargo, chemical, product or crude, there can be some small differences, but generally it is same. Start the pump slowly, then keep the discharge valve closed, slowly open the discharge valve. And once everything is okay, no leaks, pump is okay, no noise, then slowly you can go to maximum rate. Now discharging different parcels, that is, if you are using 2 pumps for the same line, which is called running the pumps in parallel or series. So first we have to make sure that cargo temperature is good. If it is not, then we will recirculate the cargo. And hydraulic oil also temperature should be okay. So if hydraulic oil temperature is not okay, we'll recirculate the hydraulic oil half an hour or 1 hour before starting the pumps. And pump should be run around 1 minute before opening the manifold valves to avoid backflow, so that there is a discharge line is full of cargo and pump is never running dry, because initially we are starting very slow, so very less liquid will go slowly. So once you see how we will know that cargo has reached the manifold, you will see some pressure in the manifold, that means cargo has reached, and then you can start opening the valves and you can hear some sound and movement. So hydraulic oil pressure should be generally slightly above the highest consumer pressure. So generally the pumps you are running up to maximum 160, 170 RPM. So the hydraulic oil pressure can be around 180, 190 like that. So when you are using 2-3 cargo pumps in the same cargo line, so you have to keep monitoring that each pump is discharging properly. So different pumps we have to set with different pressures depending on the distance from the manifold. So it will depend on the size of shorelines and size of the pumps and distance from the manifold. And you can say how much is the designed manifold pressure. So if a manifold pressure required is 8 bars and you are using 2 pumps, so you can increase the pressure slowly. So this is the head and capacity curve. So if the head is very high, the capacity is, you can see this much. And if head is very low, the capacity is very low. So if pump needs a positive net, positive suction head. So if the pump is submerged in cargo, it will discharge to this capacity. But when the cargo is very low, the capacity of discharge goes very low. And the more bends are there in the pipelines, the more back pressure is there on the pump. So that's why in chemical tankers, we have a separate pipeline, only one pipeline and one pump for each tank. So there are so many tanks and this thing. but still we have to connect it through different tanks. So try to avoid as less loops and bends as possible to avoid backflow and over pumping the hydraulic system pressure. So like you see, we are putting the pump at 180. So hydraulic system pressure is around 180 or 195 like that. Sometimes if you want to maintain the pressure of the pump, we can control the RPM. It's not good to throttle the discharge pressure, discharge valve. So we have to monitor the tank ullages and pressure, because if two pumps, suppose this is a shore manifold, and we want to use these two pumps, 1 and 2, to the shore. So this pump will discharge very easily, and this pump will discharge late. So if we are using these two pumps parallelly, that means if you are discharging cargo from here, if this pump has a lot of pressure, the cargo will go to this tank also, and you can get overflow also. So you have to maintain such a pressure, keep monitoring the ullage, and this pump you need to keep more RPM, this pump less RPM, and so that the cargo is going optimally to the shore and not coming back to the tanks. So this is called parallel pumps running in parallel. So instead of running 2 pumps at 100% capacity, better to run 4 pumps at 50% capacity, because the load on the pump is reduced. Otherwise, they will ask for a lot of maintenance. It's like running the car at full speed. It's better to run it at economical speed. It requires low maintenance. You can have incidents and injuries in highest maximum RPM. Then slowly when the cargo is going down, it's increase the pump RPM, because anyways the capacity is going down, and never allow the pump to run what you call in air. Then last few minutes, we'll complete this stripping and the pumps will finish. So now we are going to do stripping. Stripping means the last whatever cargo is remaining. So we will go very slow RPM, 40 to 80 RPM, and the cargo will be sucked in. But here we have a separate stripping line. So we'll see how we are using this stripping line. So this is the stripping line valve. You can control the pump RPM from here also. It's a local controller of the pump RPM. And we connect the air in the stripping line. So the cargo is filled in the discharge line, and then we'll put the air and we'll push it from the stripping line to the discharging line. And the cargo will go from stripping line to the discharging line. So we will see how it actually is going. So maximum up to 100 bar you can use the pump in this time. So you can put air or inert gas mostly if the cargo is inerted like this. Once with the sounds slowly when you do on ship, you will come to know that the cargo is fully discharged or not. So you can do this stripping sequence 2-3 times. So this is the what you call diagram for doing stripping. So this is the last part of cargo, and you were discharging the cargo from here, and last cargo you collected from here, and you put air in the discharging line. So this last part of cargo will be pushed from the stripping line, and you open this valve, take the cargo into discharge line. This valve you will keep closed, and the cargo will go into the discharge line, because it will be very less cargo, so it will be difficult to move it, go into the discharge line. So we will push it from the stripping line. Let's see how. Say cargo is being discharged here. Now the cargo is almost finished. So first we will purge the cargo deck line. That means we will empty this line with the air. We close this valve and push air. So all this cargo is collected here. And then we will blow the air here, and all the cargo is discharged to the shore, and this line is closed. Then air pressure is released. Now stripping. So again we start the pump. The cargo is collected in this loading line, and then we will connect the air here. So this cargo from this loading line is pushed into this stripping line. So the air pressure is coming, and the cargo is connected to the stripping line, and from here it is collected in the discharge line and passed through here. Okay. So for good stripping, we need to check the cargo pump's cofferdams so that there's no leak in the pump. Then tank cleaning. During the tank cleaning, we are putting water in the tank, and that time the water has to be stripped out. So again, we do the strip generally by stripping only. Or if it is more water, then you can use the pump directly. The same stripping procedure is followed. So the pumps is completed. So let's take a break. And then we will come after 15 minutes. Okay, Manish.
Yes, sir.